Here's something that should fundamentally change how you think about aging. Your chronological age, how many years you've been alive, may have very little to do with your biological age, how old your cells and tissues actually are. Epigenetic clocks measure this biological age by examining DNA methylation patterns, chemical modifications to your DNA that change predictably over time. The most well-known is the Horvath clock, developed by Steve Horvath, which examines methylation status at hundreds of specific sites across the genome. More recent clocks like GrimAge and PhenoAge incorporate additional factors and appear to predict not just biological age but mortality risk and health span with remarkable accuracy. What makes this exciting is that biological age appears to be modifiable. We're not just talking about slowing the rate of aging. Studies are now showing actual reversal of biological age according to these epigenetic clocks. The research on interventions is particularly compelling. Dietary patterns matter enormously. Mediterranean-style diets, caloric restriction without malnutrition, and time-restricted eating have all shown effects on biological age in studies. The mechanism likely involves multiple pathways including reduced inflammation, improved metabolic health, and enhanced cellular maintenance processes. Exercise shows consistent effects across studies. Both resistance training and cardiovascular exercise appear to reduce biological age, with some studies showing effects equivalent to several years of age reversal after consistent training programs. Stress management produces measurable effects on epigenetic age. Chronic stress accelerates biological aging through cortisol-mediated pathways and inflammation, while stress reduction through meditation, mindfulness, or other techniques can slow or reverse these changes. Supplementation protocols targeting specific pathways also show promise. The combination of vitamins D, omega-3 fatty acids, and probiotics demonstrated biological age reduction in one controlled trial. NAD+ precursors and other longevity supplements are being investigated for their effects on epigenetic age. Testing has become more accessible, with several companies offering epigenetic age testing from blood samples or saliva. You can establish a baseline, implement interventions, and retest after 6 to 12 months to track changes. Here's where I need to introduce some important caveats. First, different epigenetic clocks sometimes give different results, and we don't fully understand why. Second, short-term changes in biological age might not translate to actual changes in health span or lifespan. We need longer-term studies. Third, some lifestyle factors can temporarily affect epigenetic age measurements, like acute inflammation from an infection, potentially skewing results. There's also a risk of people becoming obsessed with optimization to the point of anxiety, which ironically could accelerate biological aging through chronic stress. The testing is a tool, not an endpoint in itself. A practical protocol would involve establishing baseline biological age through testing, implementing evidence-based interventions including dietary improvements, consistent exercise, stress management practices, and targeted supplementation, then retesting after 6 to 12 months. The goal should be comprehensive lifestyle improvement rather than gaming a single biomarker. What biological age reversal actually means for health span remains partially unclear. We're seeing the biomarkers change in the right direction, and they correlate with health outcomes in large population studies, but individual predictions are less certain. This is promising territory, but we should maintain appropriate scientific humility about what we can claim.